Alright, in this example, I'm going to look at writing equations from a graph. So one thing to note before we get started is that most functions are going to follow a common form where you're going to have some a factor or multiple on the outside, and then any number of zeros with the powers associated with those zeros. And I put the dots here because you can really have more than two zeros, which we'll actually see in the example I'm about to do. So to get started with this example, the first thing we want to do is identify where our zeros are at. So zeros are the same thing as x-intercepts. So when I say zeros, it's really going to be the same thing as where your x-intercepts are at. Notice in this graph, I have x-intercepts at -2 and -1. I also have a 0 at +3. So I can use those zeros to kind of figure out what my x minus, what my zeros in my function need to look like. So for instance, I can start my equation by writing f of x equals, I don't know what a is, I don't know what the multiple is yet, but I know that I have three different zeros. Okay, I have -2, -1, and 3, so I'm going to write x with 3 parentheses. Now the way this kind of works is you're going to take the opposite of whatever your zero is, and that's what's going to go in the parentheses. So this is really going to be x plus 2, the second one's really going to be x plus 1, and the third one's really going to be x minus 3. Now once again, the reason why we're getting the opposite values here is because when I plug in this -2 into the function, you'll notice that -2 plus 2 equals 0. And 0 times anything will be 0. So that's making -2 a 0 of the function. That's why we're getting these opposite values. Now, one of the things that's missing though is we don't have the degree on the 0. So I got to figure out what degree should I put on each 0. Well, if I look at -2 for a second, you'll notice that the graph through -2 looks kind of like a parabola, right? It shapes like a U, and you'll notice that it doesn't go through the point, it actually bounces back from the point. So because it bounces back and it looks U-shaped, I know that that is quadratic, so I represent that with degree 2 because quadratics have degree 2. Now if I look at the part of the graph that has the 1 or the -1 as the 0, you'll notice that it acts linear through that point, right? It shoots through like a straight line. If I were to zoom in on just that part, you see that's a straight line through here. So in that case, a straight line is linear or has degree 1, so I put a degree 1 on that 0. And then at x minus 3, or at x plus 3 is the 0, you'll notice that once again it acts like a U shape, and it goes through, or it goes and bounces off the point. So once again, that's going to be a quadratic equation there as well. Now, what we need to find is this a value, and you'll notice that this a value will help us find this last point I haven't discussed yet. And this last point is the y-intercept. Notice that our y-intercept is at 0, -2. So when I plug a 0 in for each of my x's into this function and I simplify, I should be able to get a -2 value as my function value. So for instance, I can find my a by plugging in -2 equals a times 0 plus 2 squared times 0 plus 1 times 0 minus 3 squared. And then all I have to do is solve this equation for my a. So I get -2 equals a. Well, 2 plus 0 is really just 2, and 2 squared gives me 4. 0 plus 1, yeah, it's taken to the first power, but that doesn't change anything, so that's really just 1. And then 0 minus 3 is -3. If I square that, I'm going to get +9, so I can multiply by 9 as well. And now if I look, I have -2 equals a times, well, 4 times 1 is just 4, And then if I times that 4 by 9, I get 36. And then lastly here, this is really a times 36. So to get rid of the 36 and solve for a, I have to divide by 36. So I'll get a equals negative 2 divided by 36, which can be simplified as negative 1 over 18 equals my a. So once again, I found this a by plugging in my y-intercept coordinates, 0 for my x, negative 2 for the function value, solve for a, and I got negative 1 over 18. So if I want to finish writing this function, all I have to do is plug in the a I found back into the original function. So the function equation for this graph will be negative 1 over 18, x plus 2 squared, x plus 1 to the first power, and x minus 3 to the second power. This will be the equation you get from the graph up above.